Okay, so continuing from the previous clip. So here we have dt over dx also is 1 over x. Okay, so the simplification of this will be like this. So it is 1 over x, and then this is the second part. So that means dt over dx will replace with 1 over x. So it will be 1 over x square d2y over dt minus 1 over x square dy over dx, sorry, dy over dx or dt over dt. Well, here it should be x square. Okay, so now we have the values of dy over dx over d2y over dx square. In other words, we have now y prime, and then we have now the y double prime. Okay, so if we input it into this equation, so what we get is here x square, and then here into 1 over x square will be d2y over dt square and minus dy over dt. Okay, and minus x, and then y prime is 1 over x dy over dt, and then plus y is equal to log of x, or we can replace log of x with t. T is equal to log of x, so it is equal to t. So now we can see that this equation simplifies into x square cancels with x square, x cancels with x, so d2y over dt square, d2y over dt square minus dy minus 2dy over dt and plus y, sorry, y is equal to e, yeah, y is there already, y, and then is equal to t. Okay, so now this equation is a second order differential equation with constant coefficients. So for this we immediately know that the characteristic equation is m square minus 2m plus 1 is equal to 0 for the homogeneous part. Okay, and for this homogeneous part, then we have this equation. So the double roots are 1. Okay, because it is like m minus 1 square is equal to 0, so m is equal to 1. So for this then we have the solution. Y is equal to c1 c1 its equation solution will be c1 e power t plus c2 t e power t. So this is the solution for the homogeneous part. So for the non-homogeneous part, that means we need to find the particular solution. So for the particular solution, we need to assume yp is equal to, because it is t now, so yp we need to assume as at plus b. Okay, so y p prime will be y prime will be, then that is the first derivative will be a, and then second will be simply 0. So now we can input this thing in these values over here to a, because the first one will be 0, double prime minus 2a plus at plus b is equal to 0. So sorry, t. So for the undetermined coefficient, just compare the coefficients. So it will be a is equal to 1, a is equal to 1, and then minus 2a plus b is equal to 0. So from here we can find minus 2a, so b is equal to 2a, b will be equal to 2. So therefore yp will be equal to at is 1, t plus 2. So the general solution will be then, total general solution will be then y is equal to c1 e power t plus c2 e power t plus t plus 2. Now we can replace t is equal to log x. So t c1 e power t e power log of x plus c2 e power t e power log of x, and then t was also here, and then log of x plus 2. So c1 e log of x, so that is x only, plus c2 t was log of x, yes, c2 log of x, and then e log of x is x, so c2 x log of x plus 2 plus log of x. So this is the answer. So in this way, what you have seen is that we have transformed the equation, which was second order homogeneous non-homogeneous equation with non-constant coefficients, into second order which equation here was that, yeah, into the second order this equation, second order equation with constant coefficients, also non-homogeneous. And then we applied the method for the second order non-homogeneous equation, the method of undetermined coefficients, and then we found the solution. So as I have said before that for this equation we can also apply the method of the variation of parameters, but in that case the integration will be a little bit complicated, but eventually we will get the same answer. So this is another approach which can be also applied. So in this approach, it's because of this log x that we have used this type of substitution. Okay.